Good evening, everyone. I am Greg Schneider, the co-chair of the Commission on Creation Care for the Diocese of Wisconsin, um, formerly from the Diocese of uh, Milwaukee. Um, Welcome this evening to a program we have called Solving the Climate Crisis, um, with Bob Lindmeier, who is the senior chief meteorologist at WKOW TV in Madison. Just a couple updates as we're ready to before we begin. Um, the program we just took a look at, which was there just so you can get your video and your sound set and correct, was from a series off of PBS called Weathered. Um, they are short videos, anywhere from 6 to 15 minutes in length, most of them right around that 10 minutes on different aspects of climate change. Um, so we do thank PBS for that series. It is very informative and something that you may want to check out. I'm please asking that you all keep your microphones muted throughout the presentation. Um, that will help keep the background noise down and be able to hear Bob during his presentation. If you have a question that comes up, you can type it into the chat. And then at the end of the presentation, we will look at those questions that were submitted, and then we will have an open mic for additional questions for Bob. So again, as I mentioned, Bob Lindmeier is the senior meteorologist at WKOW. He earned his degree in meteorology from the University of Wisconsin in Madison and started his career in 1980 at Weather Central, a weather consulting firm based in Madison. And while at Weather Central, Bob was involved with the debut of the first television graphics systems based on one of the first Apple personal computers. Over the years at Weather Central, he would witness the rapid development of new generations of weather graphics systems that revolutionized the television broadcast industry. Weather Central also provided broadcast services to WKOW. Um, he became the chief meteorologist at WKOW in 1989, a position he has held ever since. Bob is in his 44th year at WKOW, now as senior chief meteorologist. In 2019, he was presented with the Wisconsin Silver Circle Lifetime Achievement Award by the National Academy of Television Arts and Sciences. In 2023, he was presented with the local Broadcast Legends Award from the Wisconsin Broadcasters Association. Bob believes strongly in climate change education and has given well over 100 presentations. He is the former chair of the American Meteorological Society Station Scientist Committee, which encourages broadcast meteorologists to speak out about climate change. And so let us welcome Bob Lindmeier.
Well, good evening, everybody. Pleasure to be here. Um, yeah, I've been in this business for quite a while. And in the time that I've been a broadcast meteorologist, I've also been keeping track of what climate scientists have been saying in the research that they've been issuing over many, many years. And about 15 years ago, I was starting to get more and more concerned by what they were saying and alarmed, as the climate scientists were. And it just kept building. I was getting more concerned and alarmed. But I noticed there was a disconnect between what I was observing and taking in from climate scientists and what the general public was thinking. That there was not the same level of concern. What I found out was, with a little bit of research, there's just been a tremendous amount of disinformation out there, primarily put out by the fossil fuel industries that don't want things to change. So what I decided to use is my position as a trusted messenger to speak out about climate change, give the peer-reviewed research, and kind of cut through all that misinformation that is so readily available. If you Google climate change, you have to be really careful on what you pick out in there because so much of it is not peer reviewed and is totally inaccurate. So that I've come up with this presentation. There's a lot in it. So let's get going. And yeah, if you have questions, please put them in the chat, and we should have plenty of time after my presentation's done to talk about what your questions are. So our changing climate is basically simple, serious, and solvable. So my presentation is broken up into these three areas. So let's talk about how simple it is. In the scientific community that I reside in, when you get away from um, the political world and all the disinformation there, these statements are beyond dispute that climate change is real, it's us causing it, it's dangerous. Scientists overwhelmingly agree. And very important, we have solutions that are technically feasible, economically affordable, and politically viable. The question is, do we have the political will to enact those solutions? Human-caused climate change is widely agreed upon. 97% of all actively published climate scientists agree that human-caused climate change is happening. And virtually 100% of all the scientific research studies published in peer-reviewed scientific journals find that human-caused climate change is happening. So sometimes you can hear in the misinformation area that there's this disagreement. No, there's not. None whatsoever. Okay. So what has caused our climate change? What's been the driver of change over the millennia? Well, until recently, the changes in our climate were due to primarily three factors. There's been a gradual wobble in the Earth's axis, there's been a change in the tilt of the Earth's axis, and there's a change in the orbit of the Earth around the sun. These are all very subtle changes that happen over thousands of years. But over thousands of years, there's enough of a change to change our climate. So we've gone into ice ages, we come out due to these changes in these three different areas. But that's not what's happening now. When you look at temperature compared to solar activity, solar irradiance there is basically sun intensity. And you can see the bottom scale goes back to 1880. The red line is the average annual temperature of the Earth. And you can see how it's steadily gone up. On the other hand, though, solar intensity has been gradually decreasing. So that driver of solar intensity increasing to cause our atmospheric temperature to climb isn't there. That's not what's going on. What's going on is we've changed the chemistry of the Earth's atmosphere, and humans have done this. The atmosphere is 99% nitrogen and oxygen with these important trace amounts of greenhouse gases: water vapor, carbon dioxide, methane, and nitrous oxide. About 1% of the atmosphere has these gases in them. Water vapor is not a driver of change. It's just caught in the water cycle. So its concentration doesn't change. But we have increased the concentrations in the atmosphere of carbon dioxide, methane, and nitrous oxide, all greenhouse gases that help trap heat in the atmosphere and warm us up. This is an old science too. Evidence that carbon dioxide is a greenhouse gas. Joseph Fourier, back in the 1820s, observed that there's something going on to keep our Earth warm, that the sun intensity, the radiation from the sun itself, was not enough to warm up our atmosphere to make it livable. As a matter of fact, if it wasn't for our atmosphere and greenhouse gases, we'd be an ice ball. Eunice Foote made the connection with carbon dioxide and recognized that that gas was actually the cause of the Earth staying warmer. Savante Arrhenius was able to make a connection between fossil fuels and the burning of fossil fuels and the emissions of the greenhouse gases from the fossil fuels. And then Guy Stewart Callender was actually able to forecast out in the future accurately the warming of the atmosphere that would occur from fossil fuel burning. So it goes back well over 100 years, almost 200 years. So it's the burning of fossil fuels that have been putting the carbon dioxide in the atmosphere, and that is causing a temperature rise, both in the oceans, on land, and in our atmosphere. Scientists have measured 800,000 years of carbon dioxide concentration. It's important that they're able to put what's happening today in its proper perspective in history to be able to really figure out what's going on. They were able to do this because of air bubbles trapped in glacial ice. They've been able to drill ice cores into the glaciers and the ice sheets in Greenland and especially Antarctica as much as 2 miles down. When you extract that ice core that's 2 miles into the ice, that that ice is 800,000 years old. And within that ice, there are bubbles with the atmosphere of that time trapped. So climate scientists have a very good idea in the last 800,000 years, especially what our atmosphere's been doing. And this is one of the analysis they came up with. Skyrocketing carbon dioxide. The vertical scale is parts per million per 1,000 years. The bottom scale is 800,000 years ago to the present. So again, it's this ice core analysis. And you can see that carbon dioxide concentration was just bouncing up and down within a fairly narrow range through all these hundreds of thousands of years until the last 100 years. And you can see this huge spike in carbon dioxide concentration. And this is just due to the burning of fossil fuels. And that increase in carbon dioxide concentration and the other greenhouse gases has caused the atmosphere to warm. So this is going back from year 1 to 2020. So this is about 2,000 years worth of temperature. Now there's reconstructed temperatures in there, and they use computer modeling, climate modeling to do that. The actual measured atmosphere of the Earth, the warming of the Earth, has been basically since about 1850. That's when thermometers really started to get use and widespread. But again, you see that huge spike in the observed temperature, and it correlates with the increase in greenhouse gases. So let's start at 1850, when we have a good confidence level of the temperature, which is in white, and you see how it's steadily been going up. Not linearly, though, it's been exponential. Natural causes, volcanic activity, changes in solar intensity, that's the green line. You can see that if we didn't have the burning of fossil fuels, we'd be almost the same as we were in 1850 in terms of the average global temperature. It really won't have changed hardly at all. But when you factor in human and natural causes, and primarily fossil fuel burning, that is what's warmed the atmosphere and caused that observed temperature to climb. Another look at this is the correlation between the increase in carbon dioxide concentration since 1880. This is all coincides when the Industrial Revolution really got going, and as it spread across the entire world, carbon dioxide concentrations really went up. But it correlates with the average global temperature. Now, you know it's not a smooth line. It's spiking up and down, the average temperature, and that's just due to natural changes in our atmosphere. There's well-known effects like El Nino and La Nina, which have always been there, and that has caused our temperature to fluctuate to a certain degree. But it's just not carbon dioxide. There's methane concentrations, which have been steadily going up. A look at methane quickly. This is just Wisconsin. methane emission sources, 10% energy. Agriculture is the overwhelming contributor of methane to the atmosphere. And a lot of that is cow burps, but waste is a certain degree of that. Manures, especially being spread on fields and the like. The warming power of methane, it's one of the most powerful greenhouse gases. It's 80 times more warming than carbon dioxide in the first 20-year period. It drops off over 100 years to 30 times more warming than carbon dioxide. But it's a very powerful greenhouse gas. And this is why methane, on average, stays in the atmosphere for 10 years. So its concentration does drop off. Nitrous oxide, another significant greenhouse gas, which is due a lot to like cement production and fertilizer being spread on fields, lasts about 100 years. But look at carbon dioxide. It lasts over 1,000 years. That's the big problem with carbon dioxide. Once we reach a new concentration level, that's our new normal for many generations to come, unless we can figure out a way to extract it. And I'll touch on that a little bit later. So we've had this warming of the atmosphere due to the burning of fossil fuels. This is one way to depict it. It's the departure from the 1881-19 average, which is kind of the baseline. And the average global temperature did fluctuate between above and below normal for a while. Through 1880 through about 1930, we had a few below average years. But look at this. Since about 1935 approximately, every year has been above average. But not just above average, but more and more above average. And this is, again, it's not a linear climb, it's an exponential climb. This is one of the things that has alarmed climate scientists so much, is how fast the Earth is warming, much faster than any natural effects that we've ever observed. Another perspective on this is the 10 hottest global years on record have been the last 10 years. Now you'll notice that like 2001 is the third hottest. 2023 is the hottest. 2020. So they're mixed in here a little bit, all the years, and that's just because of natural variation, El Nino and La Nina primarily having its influence on that average global temperature for the year. But the last 10 years, hottest on record. And this is just a depiction of that. And you can see how the surface air temperature and how just one second here. Okay, the surface air temperature anomaly, and this is the average temperature for the globe, and you see where it's been concentrated, the warming. Below normal in blue, not many areas in 2023. Look at all of the world which experienced above normal temperatures for the year. Especially Canada was very warm. So this warming has had serious implications for us in primarily two ways. Seas are rising due to the melting of glaciers and of land ice, and that's caused seas to rise. There's also thermal expansion of the oceans as the oceans warm, and there's also wild weather. This warming of the atmosphere has caused our atmosphere to become very turbulent and produce these extreme weather events. But it's just not other parts of the world, it's happening here. Now I'm based in Madison, so I've put Madison in here. This would be a little Madison centric when I really drill down in Wisconsin. But I have these numbers for Eau Claire, Wausau, Milwaukee, Green Bay as well. And if you want them, I can get them to you. But warming at all levels. So for the United States, 2.6 degrees C warming just since 1970, Wisconsin's 2.8, Madison's 3.3. In general, Wisconsin's about 3 degrees warmer than average than the United States. And we're warmer than the global average, primarily due to the influence of Canada and the Arctic, which is the fastest warming part of the world. But our warming is not divided up is not even through the seasons. It varies. Wintertime is by far our fastest warming season. Spring, summer, and fall are also significantly warming as well. So seasons are shifting. Our summers are getting longer. The winters are getting shorter. And I think we've all observed that, right? Winter warming, average temperature for Madison, and again, these numbers are representative for other locations in the state as well, about 5 degrees Fahrenheit warmer just in the last little over 50 years. A significant warming has been taking place, especially at night. Our warming's been very observable. It used to be back in 1970, the average coldest temperature, again, this is Madison, 20 degrees below zero. Now it's about 12 degrees below zero. And that has had big impacts on insects, in many areas, this warming of overnight temperatures. The problems with winter warming, more disease-carrying insects survive. It's just not cold enough anymore to kill them off. And also it allows insects that have been normally to our south to migrate northward into our warmer climate. We're seeing earlier blooms, more pollen is with us throughout the year because the pollen gets going earlier. And we have less snow for recreation. This is, of course, last year was terrible. Governor Evers had to declare a state of emergency in northern Wisconsin, and southern Wisconsin was hardly any better. I'm a cross-country skier. I love to cross-country ski. I had exactly 1 week last winter where I could ski. And this has huge effects on us economically because winter recreation is such a huge economic driver for Wisconsin, and it's really impacted us severely in that way. Our spring warming is not as dramatic as winter, but in Madison, about 2 degrees warmer in the last 53 years. But this warming in the spring has had consequences as well. So we are having earlier springs, and this is causing mistimings to take place between climate change and the environment. They're not matched up anymore. So we have pollinations mistimed for insects, bird food supplies are disrupted, plants are sprouting earlier. We have crop damage that's taking place. And normally, just in the last decade, we've had a severe damage to fruit orchards and also to vineyards, just due to we get a really warm spring going, but then cold air would come in because it's so prematurely warming that we would get this damage that occurs. Summer warming is about 2.6 degrees in the last 53 years. And just like wintertime nights, it's especially our summer nights that have warmed even more. And fall warming, about 3.3 degrees. So, the message here is climate change is impacting Wisconsin every bit as much, and sometimes more so, than the rest of the United States and the world. But we have rising seas, wild weather, and the impacts are threefold in 3 areas: in nature, health, and economy. Let's talk about economy. One way to measure these extreme weather events is how many billion-dollar disasters occur. The frequency of these billion-dollar disasters, and these are adjusted for time, to keep $1 billion in 1980 on the same scale as 2022. But it used to be that back in the 1980s, not that long ago, we had these extreme billion-dollar events every 80 to 100 days. Now we're looking where our frequency is. It's down at 20 or less, the number of days between these extreme events. And here's another scale on that billion-dollar disasters, the annual number of events, and you can see how it's scaled up dramatically. Now, this is being caused by two things. One is societal changes. Um, we're building in areas that we shouldn't, especially along coastlines, which are being hit by hurricanes. A big one, but it's just the buildup of our population in areas that are susceptible to extreme events, along with just the increase in wealth in the country. So, and also climate change and the contribution that climate change has on these various extreme events or these various severe weather events. Okay, so it's kind of complicated, and climate scientists are still trying to sort this out a little bit, this balance between societal changes and actual increase in severe events from the weather. Here's last year, billion-dollar weather and climate disasters, and they run the gamut: drought, flooding, hail, hurricane, severe weather, tornado outbreak, wildfires, winter storm, cold waves. We had 28 separate billion-dollar weather and climate disasters, by far the most ever recorded. And they do take on this wide range of different severe events. The impact of climate change is on all those, but to varying degrees. Um, and that is something that is still being sorted out and figured out exactly as well. But there's definitely the contribution of climate change, which has elevated how extreme these severe weather events are. The impact on health, we have shifting rainfall patterns, warming temperatures, wildfires, which cause those hazards, flood and droughts, violent storms, extreme heat, fire and smoke. And then you have the impacts: injury and death, mental illness, a big one, just stress. I mean, what they're going through in the Carolinas, in Georgia and Virginia, where the catastrophic flooding occurred. You can imagine the stress levels and the mental illness that results. We have heat stress, we have insect-borne disease stress, or contributions. And a big one also is lung disease and allergies. For us here in Wisconsin, I think the number one extreme event that we deal with is catastrophic flooding. And climate change definitely has its fingerprints here, because for every 1 degree Fahrenheit increase in the annual temperature, you have 4% more water vapor, excuse me, in the atmosphere. So for Wisconsin, it's about 3 degrees warmer since 1970. That's 12% more water vapor for storm systems to draw on, and cause rain events to be heavier. So heavier downpours, this is the change in precipitation on the heaviest 1% of days. So this is the catastrophic rainfall days. It's up 45% in the upper Midwest region, including Wisconsin, as much as 60% in the Northeast. So this is, I believe, the number one cause of concern for extreme events in Wisconsin. Current and future flood loss, estimated average annual loss in millions of dollars. You can see the scale there. It's estimated the average annual flood loss is 525 million today. It's prognosed to go up by 2% by 2050, even with the trends that we have in reducing fossil fuel emissions. 2% might not sound very much, but it's significant. Other effects that we experience here in Wisconsin from our warming climate that you might not think about. Algae blooms are increasing with climate change. The lower left picture is Lake Mendota, a well-known lake in the Madison area. And all that green was algae, a huge bloom of algae that occurred last year in the spring. So, but between the lakes are warming and the fact that we have these extreme rainfall events that flood uh, algae, the nutrients into the lakes, causes the perfect scenario for these algae to expand, including toxic algae. Another one you might not consider is poison ivy. More carbon dioxide means bigger, more aggressive poison ivy. It thrives with um, a warmer, wetter environment, poison ivy. So the concentration of poison ivy used to be back in 1950, 15 milligrams. It's up to 40 milligrams today. And you can see the projections um, that we could get to unless we really reduce the burning of fossil fuels. It could be almost double by as early as like 35 years from now. So you got to be careful when you're walking outside. I've gotten poison ivy a couple of times in the last couple of years, and that stuff's nasty. I'm sure that those of you who have gotten it can verify that. Another big one is ticks. The warming, this warmer, wetter environment that we have in general means that tick expansion is spreading northward, and that has expanded the disease risk. Lyme disease is a significant issue for Wisconsin and much more of an issue than it was 20 years ago. Mosquito days, again, this is Madison in particular, but in general across the state, we have our mosquito season is about 3 weeks longer. And this is just not the inconvenience of swatting a mosquito when you're on a picnic or in your garden. It's the disease carrying mosquitoes, Zika, West Nile, among others that you can catch. Climate change is worsening our seasonal averages, or allergies, sorry. And again, we have this longer growing season. Allergies can last longer. Here's Madison in particular. The growing season is on average 32 days longer than it was back in 1970. That's a huge increase in that growing season. From the last killing frost in the spring to the first killing frost in the fall. That's how much it's warmed. And so all those different plants, trees, weeds, grasses that produce pollen just have a longer time to grow, mature, and last. And it's especially impactful for children. 1 in 5 US children have seasonal allergies. More ER visits are happening. It just is boosting pollen, and that's impacting children's health. So that was, I could spend another half hour looking at worldwide impacts. We could talk about hurricanes. We could talk about the wildfires. We could talk about Phoenix and how it's heated up, and the mega drought that's been in the West. But I think you get the idea. But I just wanted to stress we are feeling the effects of climate change in Wisconsin. But where do we go from here? Okay, I'm going to start looking ahead now. And that all depends on us and how much we want to reduce the emission of fossil fuels and transition over to renewable energy so we don't have this climate pollution taking place. If we can do substantial cuts, more cuts than we're doing now, we can bend that curve, which is steadily climbing, and hopefully keep it under 2 degrees C. All right. 1.5 degrees C was the goal that was set up actually over a decade ago. But we're going to break through that. But you can see the line of no emission cuts. If we don't stay aggressive in trying to reduce the burning of fossil fuels, we could have an atmosphere that's by the end of the century 4 degrees C warmer than it is right now, which would be catastrophic. And just to give you an example of this is where the summer is headed. In Madison, by the end of the century, our summertime average could be 9.6 degrees warmer than it is now. By 2060, we'd have a climate similar to Bloomington. By the end of the century, our summer climate would be similar to Columbus. And it's just not that warmer temperature, but just think about the vegetation. Think about our agriculture. Think about the trees. What would it look like here? It wouldn't look anything like it does now by the end of the century. So we can't let this happen. 1.5 degrees C, that's where the Paris Climate Accord is trying to, it was the goal, that's equivalent to 2.7 degrees Fahrenheit. But we're at 3 degrees Fahrenheit now here in Wisconsin. But sea level rise, loss of coral reefs, the number of people exposed to severe drought, and sea ice free Arctic summers after 100 years, that's at 1.5 degrees C. Just go up a half degree C, not 4 degrees C, not 3, just a half degree C to 2. You have an additional 4 inches of sea level rise, 10.4 million people exposed to that rise. A loss of the whole coral reef ecosystem. It'll be gone. 410 million people in urban areas will be exposed to severe drought. And at least one sea ice-free Arctic summer after 10 years. No ice in the Arctic at all. So we can't hit 2 degrees C. Just the societal impacts, the mass migration of people from parts of the world that are too hot to live in, or where a drought has gotten so bad that they have to move, would cause incredible disruptions across the world. So that's where we're at. Yeah, 1.5 is, we're going to be hitting that, unfortunately, but we cannot let ourselves get to 2 degrees C. So the good news, though, about all this is that it's solvable. We have already what it takes to make the changes we need to bend that line and stay under 2 degrees C. So here's what's been happening so far. U.S. clean investments have been climbing steadily. This 2018 to 2023. It's not climbing nearly fast enough, but the trend is good. At least it's positive. But one of the big challenges is greenhouse gas emissions are broken up in these various sectors. We have agriculture, commercial, residential, industry, electricity, and transportation. All these different areas have to be addressed if we're going to reduce gas emissions to the level we need to. One big one is this building better, you're building better buildings and making them more resilient and not so affected by heat loss, dynamic glass, insulation improvements, electric heating and cooling, staying away from gas. All can really help. There's a lot that we can do in this area just to make our buildings more energy efficient. Cost-saving upgrades in your home. When it comes time to replace that furnace, look at a high-efficiency heat pump. Insulation improvements, energy smart appliances, using a smart thermostat, LED lighting. This is all kind of low-hanging fruit to a large degree. So I'm not talking about even putting solar on your rooftop. A climate-friendly house in Wisconsin can save in utility costs by enacting all these different things, over $500 per year, and keep 3 tons of CO2 out of the atmosphere just by what you do in your home. Of course, transportation's a huge one. Electrifying it, the trend is in the right direction, but we still have a long, long ways to go in terms of electrifying transportation at the rate that we need to. But again, the trend is in the right way. In agriculture, just building better soils, farming practices that increase soil carbon. Don't let that carbon be released from the soil into the atmosphere by growing cover crops, applying compost, doing reduced tilling, which doesn't expose the soil to the air so much. All are things that agriculture can do, and these can be done without significant costs involvement. We have these carbon sinks that are across the world that naturally absorb carbon. They include grasslands, coastal wetlands, peatlands, and forests. They're so important in absorbing CO2 and and that natural process of absorption. The problem is we're losing these different environments, especially forests are disappearing, as you know, quickly. Grasslands, coastal wetlands are a big problem as well. So we've got to stop that, where we, instead of losing these different ecologies, that we start to expand them again. Here's one you might not think of in terms of what you can do to help out in reducing the amount of fossil fuels that we use. Animal-based foods are more resource intensive than plant-based foods. So you see the dashed gray line on the left is plant-based, on the right is animal-based. And green is land use, blue is fresh water consumption, greenhouse gas emissions, and orange. Look at where beef is and all the other animal-based foods compared to plant-based foods, much less resource intensive. So anything you can do to reduce your animal-based food consumption can help. I've been I try to practice what I preach. We have about half of our days each week are not meat-based. We're trying to do more. But the biggest one is making this transition from burning fossil fuels to using renewable energy. That's the number one way to bend the curve and keep our average global temperature from climbing above 2 degrees C. So, renewable energy. Nuclear is not a renewable energy in the strict sense, but it does not release carbon pollution. So nuclear, if we can get it figured out and safe enough and economically viable enough, is, I think, an important important technology to use. And it's being used now. They have these small reactors that they're developing. Instead of the huge plant like you're seeing here, they're like micro nuclear reactors. And they're starting to be implemented more and more. Zero emission vehicles, a big contributor to reducing the amount of greenhouse gases emitted into the atmosphere. Again, transportation makes up 20% of US emissions. So the Biden administration's been aggressive in telling lawmakers or telling automakers that you have to transition over to renewables at a faster rate. And that, to me, that's a good thing. Solar power, a big one. Solar farms or solar on your rooftop. The renewable alternative to electricity generated by burning coal or natural gas. That alternative. And again, electric power makes up 25% of US emissions. And there's wind power and wind turbines and heat pumps. These are becoming more and more economically viable. And again, you should look hard at using an air source heat pump for your home, when it comes time to replace that furnace, or if you build a new home. 13% of US emissions are from homes and businesses. Solar and wind are viable across the entire United States. There's solar you can see in the upper left and wind in the lower left. In Wisconsin, both can be used. Solar generation in 2023 in the United States, 22.1 million homes are powered by solar. That's a 16% increase since 2022. And the solar capacity has been growing fast. It's been heartening to see both utility scale and small scale, which is primarily residential rooftop. They're growing steadily, and it's just not people being ecologically sensitive. It's just economics are driving this. It's just so much cheaper now to put a solar farm in place than it is to build a new um, coal-fired power plant. The economics are just there to make it grow and grow. The trouble is it's still not growing fast enough. In Wisconsin, 142,000 homes are powered by solar generation. That's a 48% increase from 2022 to 2023. That's nice to see. I have solar on my rooftop, and I love it. Works great. Wisconsin solar capacity has really taken off. But the thing is, as recently as even 2019, we had hardly any solar capacity. We were behind the curve of many states, but at least it's ramping up quickly now. Uh, Top technologies, clean technologies by state. For Wisconsin, it's solar, but it depends on the state. Because zero emission vehicles, wind heat pumps are all in other locations the top technology. Here in Wisconsin, it's by far solar is the clean energy investment. That's zero emission vehicles are significant as well. But okay, so the economics are driving this to a large degree. Wind and solar are cheaper than fossil fuels and gas for that matter, which is the popular one, unfortunately. Gas turbines use. But it's not enough to make this transition happen fast enough. So what the Biden administration did 2 years ago was enact the Inflation Reduction Act. And this is kind of like giving it's carrots. It's to all the different ways of developing renewable energy. It's encouraging investment, tax credits, making it cheaper than it is now. It has a really nice effect. The target is by 2030 to have our annual greenhouse gas emissions to be 50% of what they were in 2005. So over that 25-year period, we want to drop it by 50%. And we need that kind of drop to get where we want to get to. Now, IRA does not do it all by itself, but it's getting us pretty close. There's also the EPA has put the standard on fossil fuel power plants to reduce pollution. And so that's a new way of getting power plants to reduce their fossil fuel emissions at a faster rate. And you can see what that policy and its effects would be from 2005 through 2030. Pre-IRA, you can see where the trend was in the United States, not nearly fast enough. IRA plus federal regulations like this EPA standard have got us to 40 to 42% reduction by 2030, but we want to get to 50 to 52%. So we're still not quite there. But one thing that we can do that would get us there is put a carbon price on carbon pollution. This has been known for years. Economists have got it figured out. How much damage does 1 ton of CO2 do on our economy? And so you can look at the greenhouse, look at the emissions of carbon dioxide from oil, from uh, from uh, coal burning, and figure out a damage cost. Okay. Oops. Got that in there twice. Okay. Now let's go ahead. There's a bill in Congress right now. It's called the Energy Innovation and Carbon Dividend Act, and this addresses this carbon fee. So the way it works is to charge a fee on fossil fuels at their source. This fee recoups the damage that carbon emissions are doing in our economy. Instead of us paying for it out of our pocket through insurance, through our taxes, this is where you want that fee to come from. Now, if you do that, of course, if you increase these different fossil fuels, mine well, or bringing it in from a port, you're going to bring up the cost of energy a lot. Inflation will increase. The way you counteract that, though, is return 100% of the net revenue to households as a dividend. This does not go to the government. It comes to us as a check. And that check helps to reduce that cost that we have to incur from the increased costs of burning fossil fuels. The benefits of this net zero, we reach it by 2050. We get there. We have affordable clean energy. We get there much quicker. That saves lives in many ways, just from air pollution, not to talk about climate change effects, air pollution effects. And it actually puts money in your pocket. If you have, it's been analyzed, they did an analysis of this, that if you have a small enough carbon footprint, you will, at the end of the year, not only recoup the additional cost of energy, but you'll have money in your pocket, which would be an economic driver for the United States. Now, if you have a McMansion and if you drive a huge SUV, yeah, you're not going to have money left in your pocket, but it will give you incentives to get away from that. The last thing I want to touch on here, and I'm almost at an end, is a lot of climate scientists, and I'm tending to agree with this as well, just the way we're trending is that even with all these things, and the carbon fee and dividend just is not realistic right now, given our divided government. But there's climate restoration. The goal is to reduce the level of carbon dioxide and methane in the atmosphere to pre-industrial levels using a wide array of technologies now in development. You might have seen this on 60 Minutes a couple of months ago, direct air capture, where they literally extract carbon dioxide from the air. You can convert landfill methane to our renewable natural gas. We're doing that in Dane County right now. It's implemented and viable. That's one that any county can do right now. Convert garbage into sustainable aviation fuel, regenerative agriculture, enhance ocean atmospheric methane removal, kelp forests in the oceans, carbon mineralization using enhanced rock weathering. The problem that we have right now in climate restoration, aside from the convert landfill methane and RNG, is making it scalable enough to be impactful and affordable enough. But the IRA has been putting money into these different technologies, and I'm hopeful that some of them will bear fruit because we can use all the help we can get. Okay, one question I always get, and again, I'm close to the end here, going a little bit longer than I'd hoped, but the top carbon dioxide emitting countries. All right. Through history, if you go back to 1750, through the Industrial Revolution, the United States by far has put more of the existing CO2 in the atmosphere there, almost 25%, followed by China, 14%, and other countries that have also contributed. But by far, the United States is the reason we have the problem we have right now. Okay. But the thing is, currently, things have shifted. China is by far the main contributor of CO2 in in the world right now, 28%, followed by the United States, the rest of the world. India is a big contributor. So obviously, it can't be just us. The rest of the world has got to go along. So a lot of people point at China, but keep this in mind: electric generation per year by solar and wind power. Solar has, for in China, terawatt hours, so far ahead of the United States in terms of the generation of solar. Wind, so far ahead of the United States. That shouldn't be. There's no reason that we shouldn't be matching China in the expansion of solar and wind. They're ahead of us by a uh, large measure. Now, it's granted they're still building coal-fired power plants in China. The problem is there that much of the country still is not electrified. We're electrified. They're still dealing with that issue. Electric vehicles, China, 29% of sales is electric compared to the United States at 8%. As of 2022. So before we point at China, I always tell people we have to get our own house in order here. Because generally what the United States do, the world follows, because we are still the number one economic power in the world. What we do will have a huge influence on other countries. To finish this up, for sure, what can you do? All right. What can you do as an individual? Here's a big one. Have conversations with your family, friends, and neighbors about climate change. Bring it to the forefront. Make it something that people think more about. It's so easy in this day and age with our economic problems, with our political problems, with every other problem that we have going on, that climate change can kind of be pushed to the background. We have to bring it to the forefront. Big one coming up in less than 2 weeks: vote for candidates that advocate for climate change solutions. Not just that they believe the climate is changing, but that it's human caused and we have to do something about it. And this is through all levels of government, from your state, from your school boards to your village government, all the way to the President of the United States. Join an environmental organization. It's so easy to feel helpless. You watch the news on TV, you see these catastrophic occurrences happening, but you can really empower yourself by joining an environmental organization, and join or create a care for creation team. If your church does not have a care for creation team, by all means form one. We formed one at my church. I'm ELCA, so it's a Lutheran church, but we formed one primarily to get solar in our roof, and we did. We got it installed and running about 3 years ago. So to sum up, it's simple. It's well understood science that goes back to the 1800s. It's serious. Impacts are already being felt and will only accelerate, but it's solvable. We have what we need to make changes. This is why I'm talking to you this evening. This is why I'm taking time out of my day. It's because of my kids and grandkids. These are my three grandkids, my three girls, ages 5, 7, and 10. What's the world going to be like for them in 50 years? Unless us, make the big changes now before they have the power to do it, unless we make those changes, the world is going to look so much different than it does right now. But it's just not my kids, your kids, our grandkids. It's just, it's the children of the world. So that's my presentation If you want to get a hold of me, there's my email, boblindmeyer@gmail.com. That's the best way to get a hold of me. And yeah, and we can follow up. If you want the presentation, I can give it to you as well. So let's unshare. Stop share. There we go. All right, kind of screwed up the timeline here a little bit. I've gone well into the Q&A, but I'm more than happy to answer any questions that you might have.
Right. Thank you so much, Bob, for your presentation with a lot of great information
Mhm.
on what is happening, and what we're seeing and why that is, as well as the great suggestions on things that we can do to go forward. So if anybody has any questions right now, if you want to unmute and ask your question, please go ahead.
I think
Sure,
there are a number of
I'll read
questions
some in
on
the
the
chat.
chat. On the chat.
Okay, yeah, and actually I see some of those in chat. So I can address those questions first in chat. Okay. And one that I'm seeing here is, why are the temps rising more in colder climates? And that's just due to the fact that, you know, that's a good question. And off the top of my head, I don't have a really good succinct answer, but I can definitely come up with one. But unfortunately, I don't want to sit here and think about it. I want to keep things moving. Um, Samantha's in seventh grade. Do you have some ideas for students my age for helping to stop climate change? Samantha, number one, it's great that you've been listening today and watching my presentation, because the number one thing you can do is just educate yourself, like everybody. Get yourself educated on the subject. And then I think just have conversations with your friends, as I mentioned before. Have conversations. You could, in the next few years, try to uh, make a school group with the help of your teachers. You can get a group going that talks more about climate change. And there are organizations, youth organizations that you can join as well. Will the melting Arctic be responsible for more severe winters in North America? Um, you know, as the Arctic warms, we're going to continue to warm. That's the number one thing. So, but one thing that the warming of the Arctic has done is cause more variability. We're seeing more pendulum changes. We'll go from an extremely cold week. In last winter was a great example. We had brutally cold weather, record cold for about a week, right? But then within days, it warmed up dramatically and then just stayed warm. That's kind of a microcosm of the way our winters are going to be. We're still going to have our cold waves, but the main thing is the duration of those cold waves will not be nearly as long as they were, say, 50 years ago. What can utility companies do to incentivize installing and using solar? You know, that's an issue that we have in Wisconsin. It depends on the utility company. Some are more friendly to residential rooftop solar than others. They make it more cost effective to do some utilities more than others. But anything that the utility can do to make it more financially viable for a residential customer to install it, the better. I live in Oregon, just south of Madison in Dane County. We have Alliant Energy, and they're not bad in terms of what they've done. They've been helpful. They have not obstructed at least. But there's more all utility companies can do. But the problem there is every solar top that goes on a roof, it means less electric production on their end, and that's taking money out of their pockets. So there's that financial aspect that is challenging when it comes to utility companies. Do the hurricanes moving over the ocean lower the ocean temperature? They do temporarily. Like our last hurricane, which went from southwest to northeast over the Gulf of Mexico. That area had not had a hurricane for a long time. So the surface temperature of the ocean had really been able to warm up unbelievably. I mean, the warming of our oceans in general is just jaw-dropping to climate scientists. It's happening faster than the computer models had progged. But the thing is, once the hurricane goes over that water, churns it up, it brings colder water from lower levels to the surface. But that's temporary. That's just temporary. And then within, I don't know how long, a few days to a few weeks, that warm surface water starts to form again. How do we create the political will for action? That's where I think being part of an organization helps. Being part of 350.org, the Sierra Club. I'm part of Citizens Climate Lobby, which advocates for policies in Washington that help this transition to renewables. It's hard to do anything by yourself, but if you do it as part of a group, then you can enact change. So a lot of the political will comes from our government being willing to buy in, and that's where the vote is so important. Making sure we vote for people that believe in climate change and want to make changes. In addition, so I've covered. Oh, here's another one. Okay, we'll just go along. As a youth, I played outside a lot. Now with ticks and Lyme disease, etc., there seems to be a fear of being outdoors. Yeah, that's justifiable. But I think you just have to be really conscious of your environment and staying away from areas where they have ticks, tall grass, when you go through it. Because, ticks love to be in grassy areas. They just do a little jump onto your body. So just staying out, with the help of your parents, you can know. Because if you're just like on a lawn, if you're out on a ballpark field, if you're in a park with just short grass, you're pretty confident. I personally don't worry about ticks in that situation. But when you are in a place where ticks can be out there, the number one thing is when you come back in to really carefully look at your entire body, including your scalp, all of your skin, because those ticks are pretty small, and make sure that one is not there. But I wouldn't let that deter you from going outside and playing. You just have to be smart about it. Who are the champions now for reducing carbon emission? I think the number one needle mover has been the Biden administration and what they've been able to do in enacting laws, despite our divided government, that they still were able to implement IRA. I was talking about the EPA rules that they've enacted. So IRA was just a huge game changer. We couldn't get a carbon fee and dividend enacted. We actually came pretty close, and now we're pretty far away. But IRA is going to be still having effects over the next few years. So yeah, I think our government is the number one champion right now, but that could change dramatically in November. Ira is the co-chair of this committee. Oh, that's cool, Ira. I'm not sure if you had anything to do with the IRA, but that's funny. Anything else? That's kind of the chat right now. And you can unmute too and just ask me a question. You don't necessarily have to go through the chat.
One of the things that has come up in
Yeah.
discussion is we look
Oh,
at
Greg is already.
places that were climate havens,
Oh, yeah.
cities that were declared that, like Asheville,
Yeah.
North Carolina, really are not.
Right.
Are there any areas that
Didn't
you
answer it. I
think
didn't hear
of that would be more of a climate haven or a safe place from most of the severe storms?
Yeah, and you might have seen like the 60 Minutes story where there was a climate scientist that actually went to Asheville believing it was a climate haven. And it turned out that it wasn't.
He's animals.
It looks like we need some muting. Hello, people. Please mute if you're not on right now. Just hearing it. But anyway, so kind of lost my train of thought. What was I talking about? I lose my train of thought so easily in my age.
The climate scientist that went to Asheville.
Oh yeah. So yeah, climate safe areas. One of the number one areas is Duluth Superior. Wisconsin in general is an area that is much less influenced by climate catastrophes than the rest of the United States, but we still get it, right? I mean, we can have terrible blizzards and we can have tornado outbreaks. Iowa was just pounded by that line of severe thunderstorms that produced the huge hail and the hurricane force winds. It was a derecho. We can get derechos in Wisconsin, just like Iowa got that bad one. So we are not completely insulated from the influence of climate change and its ability to make extreme events more extreme. But overall, we're in a pretty good area right here.
Okay,
I'm going to have to drop out, but thank you very much. Is it Robert or Bob? Thank you for your presentation. And if you could make your presentation available, I'd appreciate it.
Yeah, just email me to
you.
boblindmeyer@gmail.com and I will send it to you. And you can use it. I encourage people to use it as much as you feel free. You can use it kind of as your own basis. And wherever you live in Wisconsin, there are graphics that you can get not only for Madison, but for, again, Milwaukee, Green Bay, Eau Claire, Wausau are the cities, and La Crosse in Wisconsin, that they have these specific graphics for your location. It's Climate Central. You'll see it on the graphic. You can just go into that website, pull it out, and modify accordingly.
Listen, you have a good evening. I'm sorry, I just got another commitment here that I have to take off. Thank you very much.
You're welcome.
Okay. Any other questions that are out there? Any others? Okay. Bob, again, greatly appreciate your time and all the information that you have shared with us. It is very helpful as we begin and continue thinking about the different aspects of climate change and what we can do to help protect all of creation as we look at that. So thank you so much for your time. And again, we pray for your continuing efforts to help us all solve the climate crisis. as you share your words with everybody else. Just as a comment, this presentation has been recorded, and so the recording should be available on our web pages as soon as they are up on the Diocese of Wisconsin's website, or if you email creationcare at gmail or at diomil.org, we can send that out as soon as we have it ready to do that. So we thank you, Bob, and also we thank PBS for its many programs that it has, or that they have on the many aspects of our changing climate, especially for weather, which we shared before tonight's presentation. Again, as I mentioned, our web pages are being transitioned. Hopefully within the next week or so, those pages should be up, and you'll be able to find this presentation and several others that we have, along with a lot of other information to help us care for all of creation. So just also as a reminder of the different groups that we are partnered with as we work to care for creation. Again, Province 5 of the Episcopal Church, their Creation Care Network. Faith in Place, which do have people that are available to help any church who wants to create a green team or a creation care team. So if you let us know, we can get you in contact with them. Interfaith Power and Light, and Focus on Energy, which is a great place to go for information on ways that you can reduce your carbon footprint. And of course, the Episcopal Church, their Creation Care website has a lot of other information and a brand new curriculum that is out to help look at creation care. So now we will actually end this presentation and this broadcast, and hopefully that then as you are in your watch party, if you have time to take a look at some of the questions, and of course, the moderator has those questions for you, but they are also here on site. Again, taking a look at what did you learn tonight? What do you think? Why do you think we're in the climate crisis? What can we do for it? How can we help our neighbors? And of course, our non-human neighbors, as we look at the extremes of the weather that we are going to have now and in the future as we go forward with this. So again, I thank you also very much for being with us this evening, and hopefully this was very informative. This will be up, and again, thank you so much, Bob.
My pleasure. It's a pleasure to give my presentation. I loved being able to talk to you today.